Welcome to clickmyproject.com. Now let's see about a layered approach for ECG beat classification using neural network. Now let's see this abstract. It is a novel method to detect the disease in ECG signal. For detecting the ECG signal, we use the neural network for identification. It has the process like signal processing, feature extraction and classification technique, and then we decompose the image by the use of empirical mode decomposition, and neural network toolbox will be used for MATLAB environment. EMD is a method of breaking down a signal without leaving the time domain. It can be compared to the other analysis method like Fourier transforms and wavelet decomposition. The process is useful for analyzing natural signals which are most often non-linear and non-stationary. EMD filters out function which from a complete and a nearly orthogonal basis for the original signal. Completeness is based on the method of the EMD. The way it is decomposed implies completeness. The function known as intrinsic mode function are therefore sufficient to describe the signal, even though they are necessarily orthogonal. The classification steps of the signals are which is distinguished from the various stages from the data acquisition, its pre-processing, extracting features, training the neural network. Finally, it will predict about the ECG signal. This is the flow of a process. Here we have to give on the input signal. It should be the ECG signal. The ECG signal passes to the pre-processing stage. In this stage, we are filtering the Gaussian noise. Gaussian filter is often used to remove the noise from the image. Here we used to VNR function to remove the noise. After removing the noise, it's go to the EMD decomposition. EMD is a method of breaking down a signal without leaving the time domain. It can be compared to the other analysis method like Fourier transforms and wavelet decomposition. The process is useful for analyzing the natural signals which are most often non-linear and non-stationary. These parts are from assumptions of the method we have thus for land. At least the EMD filter out function which from a complete and nearly orthogonal basis of orthogonal signal. Completeness is based on the method of EMD. After this EMD decomposition, it will go to the peak point detection. In peak point detection, R wave is identified there. R wave is the most distinct component available in the ECG signal, which is normally detected by the lower order of IMFs. Normally, this type of R wave also contains the high frequency component, but using EMG noisy ECG can filter out the complex QRS and its associated uneven waves. These patterns can be denoted as IMFs. After that, it will go to the neural network. Neural network is a machine learning approach that models human brain and consists of number of artificial neurons. Neurons in an ANS tend to have a fewer connection than biological neurons. Each neuron in ANN receives a number of inputs. Activation function is applied to this input, which results in activation level of neuron. After that, it will go to the result. Based on the training neural network, it will identify the result of ECG. Now let's see the demo of the process. Here I am having ECG main data file. Select this file, right click and run the file. So this is our guide design. So we have to given the input signal. In database totally I am having 14 images. Now I am selecting an image as input. So this is the selected ECG signal. It will go to the pre-processing step. In this step we are filtering the noise. So noise free signal is taken to the further process. After that we are going to the EMD decomposition of this pre-processed signal. This is the EMD decomposition result of this signal. After that, we are going to identify the feature points. For the identifying these feature points, we are predicting the R peak direction is identified there. The detected peak points are extracted as features. These are the result of our peak points detection, and then the features are stored here. These are the feature values of the provided input signal. These feature values will go to the neural network. The neural network will identify about the ECG signal. Now it classified this result as normal. Now I am showing the result of ECG bit classification using neural network. It identified the disease in the ECG signal. Thank you.